The next question asks us to find an absolute extrema, if it exists, for all of the values of x where they occur on the given interval. So we have to remember the process of finding absolute extrema. First of all, we need to know if there are any relative extrema within our given interval. That means we're going to find the derivative of the function and look for critical numbers. Once we have those critical numbers, we're going to use them along with the endpoints of our derivative to determine what is the highest value for our function on the interval and what is the lowest value of our function on the interval. So, to get started, we do need our derivative. So our derivative of g of x uses just the power rule. We're going to get negative 3x squared plus 12x. So in order to find critical numbers, we have to check two things. Where is this derivative undefined, and where is this derivative equal to 0? And of course, we can notice that g prime of x is never undefined. It's a polynomial. There's no division by 0, there's no square roots of negative numbers, so we don't have any mathematical problems. That means we only have to check where our derivative is equal to 0. So we'll notice that we can't use regular factoring here because we only have 2 terms instead of 3. Now, sometimes that causes students to get stuck because they forget there's actually an easier way of factoring. If you only have 2 terms and not 3 terms, you don't have to do the AC method or trial and error or anything crazy. All you do is you look for what is the greatest common factor and you take that out. So my numbers are negative 3 and positive 12. They share a factor of negative 3. My variables are x squared and x. They share a factor of just x. So what's missing? Well, in my first term, I'm missing a factor of x. In my second term, I'm missing a negative 4 because negative 3x times negative 4 would give me positive 12x. So using the zero product property, that means 0 is negative 3x or 0 is x minus 4. If I solve the first equation, divide both sides by negative 3, and I get x is 0. If I solve the second equation, add 4 to both sides, and I get x is equal to 4. But notice what's going on here. Our interval is from negative 1 to 3. And so we notice even though x equals 4 is a critical number, it isn't in the interval. So that means we're not going to use it. One way that I like to do this mathematically to remind myself that I could get critical numbers that are not used in my interval is I always write down my interval values x, followed by my function value g of x, and I do them in order. So what I mean is I start with my first endpoint value, that's negative 1. And my last endpoint value is 3. So now I'm going to place in between these two numbers any of my critical numbers that fit numerically. 0 is between negative 1 and 3, but 4 is not. So I'm not going to use the 4. Now, the other thing that we have to be careful about is we need to remember that we're plugging these values into the original function in order to determine where we have a max and where we have a min. So let's do this. You can use a calculator if you'd like. If I plug in negative 1 for x, I'm going to have negative 1 times negative 1 cubed plus 6 times negative 1 squared minus 2. That's going to give me 1 plus 6, which of course is 7, minus 2 is 5. So I'm going to get 5. What happens if I plug in 0 for x? Well, that's really easy. If I plug in 0 for x, I just get negative 2. And what happens if I plug in 3 for x? Well, I'm going to get negative 3 cubed plus 6 times 3 squared minus 2. So I'm going to do a little bit of scratch work off to the side because I don't have a calculator with me right now. Negative 3 cubed is negative 27. 3 squared is 9 times 6 is 54, so plus 54. And then I have a minus 2. So if I figure all of this out, this is going to be negative 27 plus 54 is positive 27. And then positive 27 minus 2 is going to give me positive 25. So now I've got to make a judgment call. What is the largest value that I see for my function? That's going to be the absolute max. So the largest value I see is 25, so this is the absolute maximum. What's the smallest value that I see for g of x? Well, that's negative 2, so that's going to be the absolute minimum. Now, if we were being formal about it, we can write down as our final solution that g of x has an absolute minimum at x equals 0, or I should say a maximum minimum value of negative 2 at x equals 0. And it has an absolute maximum value of 25 at x equals 3. So the x value is where it occurs. The actual max or minimum value is the output or the y value, the function value that you got from this process. Okay, so we'll look at another video in the next one.